we learned that we can create variables before that store a Boolean. And we can actually use these variables now with the if statement. So let me show you an example. So for example, I can create a Boolean, for example, at the top and say Boolean, let's say bad denominator. Okay, so at the beginning, I'm going to set it to false. I'm going to assume that the denominator is not bad. And then I can come here and say if denominator equals 0, then I'm going to set this bad denominator to true. So we can start using these variables that are Booleans. You can set it to something like, have an assumption at the beginning, and then if you find like a problem, change your variable to something else. And then I can here, for example, say if bad denominator, because this is a Boolean, because this variable is a Boolean, I can actually use it in an if statement, because this if statement takes a Boolean expression, takes an expression that evaluates to true or false. But if you already have a variable that's true or false, you can just use it. So I can say if bad denominator system.out.println, you cannot divide by 0, for example. So what I did here was I created a variable that stored a Boolean, the false. I changed the value of the variable depending on some condition, and then I'm using this variable inside the if statement, because the if statement, like I said, takes a Boolean expression. And so now if I run this code and I enter 1 for the numerator, a 0 for the denominator, what's happening is the 0 is getting stored here. It's coming and checking, is the denominator 0? Yes, it is 0. It's setting the bad denom to true, and then it's checking. If that is true, it is true. It says you can't divide by 0, and that is why I am getting this statement. The code moves on and checks, is the denominator not equal to 0? Well, 0 not equal to 0 is false, because 0 and 0 are equal, and so it's going to say it's not going to go and do what's inside this if statement. Now, let's run it again with the opposite. Let's give it a good denominator. Now here the denominator is 2. It's going to come and check, is 2 equal to 0? 2 is not equal to 0. So this evaluates to false. So it skips over, it doesn't do what's underneath, and then it comes and checks, is bad denominator true? Well, bad denominator is false from the beginning. We never changed it because this never happened. And so this is false, so it doesn't do what's underneath, because with the if statement, it will only do what's underneath if the if condition is true. And then it comes back down here and checks, is denominator not equal to 0? So we check 2 and 0. Are they equal? Not equal is true. They're not equal. 2 is not equal to 0 is true. So it's going to come and print out the answer is and the 0.5. Okay. So this is something else that we could do, have those flags. Now, we can compare characters also. So we can compare numbers, greater than, less than, equal, not equal. We can also compare characters. How do we compare characters? Well, characters are stored as Unicode. Every single character, we said before, is stored as a number in binary. So if you look at A, for example, it's stored as 0, 1, bunch of zeros, and a 1. Well, what is this number to us? This number to us is 65. So A is 65, B is 66, C is 67. So I can actually compare letters. If I ask A, are you bigger than B? It's going to say no, because 65 is not bigger than 66. So when you're comparing characters, you're basically comparing those numbers, how they're stored. They're Unicode. Notice that uppercase letters and lowercase letters are not the same. So uppercase A is 65, lowercase a is 97. Uppercase letters are considered smaller than lowercase letters. But I can compare them. So here I have a character, last initial is K. Remember characters, we put single quotes around them. And then I'm asking if this last initial is before M, so if it's a letter that comes before the letter M, I'm going to say you have to sit before like Mickey Mouse, for example, or whatever. So this is helpful when you're trying to sort characters. Let's take an example with characters. So here, let's ask the user system.out.println, enter your middle or your last first letter of your last name. Okay. Now, when the user enters that letter, I'm going to go to keyboard, and remember, keyboard doesn't have a next char. It has a next line. And then we learned that the string has a char at method, where if you give it a number, it gives you the letter at that number. So since we're expecting them to enter just a single character, that means the string that they're going to enter has only one character. So we can get what's at char 0. So here is the letter that they entered. Okay. So I go to the keyboard, I get whatever they entered, and I get the first character of that. And then I can say, for example, if this letter is less than I say system.out.println, you are in group A, for example. Imagine I'm breaking up my people, the group of people, my students, into two groups. The students that have a last name that is starts with anything before M. If I wanted to include M, I can put an equal sign here, and then maybe another group. So let's test it out. So, oops. Ooh, we ran into that problem. Can you see what I did? It said enter the first letter of your last name, and it didn't wait for me. Why isn't it waiting for me? Remember, next line is going to search for an enter. There is an enter that we typed after the last number, so we need to ignore the enter. So let's ignore the enter. Let's go to keyboard and say next line. We are reading in, read in the enter, press after the denominator. Let's try again. Okay, so numerator is 1, denominator is 2. Now it's asking me, and if I say apple, oops, A. I have to make uppercase A because we're comparing uppercase letters now. It says you're in group A. But if I give it, for example, T, which comes after the letter M, it doesn't print anything because this if statement does not evaluate to true. And if I was to enter M, it will evaluate to true because M less than or equal. Yes, it is less than or equal. So let's try it with the letter M, and it says you're in group A. So I can compare characters also, but I just need to make sure I compare them with the less than and greater than signs, and I match the case. So if I'm expecting whatever the user to be typing in to be uppercase letter, I have to make sure that I have an uppercase letter. If it's a lowercase letter, then I use a lowercase letters. We're not going to learn in Java 1 how to convert characters to uppercase or lowercase, but we did learn how to do it with a string. So if I wanted to make sure like everything was uppercase, I can say next line dot to uppercase. So make sure I convert anything to uppercase before I do the test here. Okay. So let me show you what happens if I don't have that and I do have it. So for example, let's run it and have the user type in lowercase a. Nothing got printed because lowercase a is actually bigger than uppercase M because we said the lowercase letters come after. So if M is down here 70 something, lowercase a is 97. It's bigger. So this evaluates to false. But if I want to make sure that I am ignoring the case, then I can just convert everything in the string itself, convert it to uppercase before I get the first character. So it's going to take whatever the user types in, converts it to uppercase, and give me that first character that is after the conversion. So now I should get that a person with starting with A, I do get that they are in group A. So here I'm kind of like ignoring the case when I'm doing the comparison by saying I'm going to make sure everything is in uppercase because I am testing my, my code in uppercase.